Last time we looked at two different measurements for data. What was one thing we were measuring last time to review? We wanted to measure what about a set of data, because we want more information than just a list of numbers. So last time reviewing, we did, what were those notes on? What were we measuring?
Mean.
The mean. Okay, let's start there. Mean is a measure of what? The average, which tells you where the center of the data is. The mean is one way. What's the other measurement of center?
The median.
The median. The median. So those are the two measures of central tendency. Those are the most important ones, the mean and the median. Those are the most important. And then we talked about, what was the other thing we measured? Center and spread. How spread out is the data? So there's two ways. Well, there's one main way of measure. Well, there's a couple ways. How can we measure that? How spread out the data is. What tells us that? What number? The standard deviation, right? Tells us how far. What it means is how far on average are the numbers from the average. And if you know that definition, it'll help you use the formula for standard deviation. If you know what it means, because you have to know that. What's another measure of spread? Standard deviation and the range, right? You subtract the max from the min, and that tells you another measurement of how spread out the data. Okay, so those, but now what we want to see is we want to look at the shape of the data. Those numbers don't really tell us the shape, so we have to graph the data to look at the shape. Okay, so this is really about measuring the shape. So I'm going to give you a set of data points. So we have, I'm going to start putting them in order. Okay, 77. We're going to do everything with these numbers. 77, 77, 80, 85, 85, 88, 90, 90, 95, 100, and 100. Okay, so that's our data set we'll use for everything today. And I already wrote it. You definitely want to put your data in order, so it's already in order. What might these numbers represent in context of a real problem? What might these numbers be? Okay, they might be test scores, right? Percentages. Okay, so the first form, right now, even though the list is in order, it doesn't look like anything. So one thing we can do is a dot plot. And it's kind of like saying, it's kind of like we're looking at the frequency. So we'll do a dot plot. So what you do is you make a number line. And we'll just start, we'll do even intervals, 75, 80, 85. You don't need to make a marker for every data value. So you start with some kind of reasonable number line, and you just put a dot wherever you have a data value. So 77 is right about here. And then we have another 77, so we just stack them. We'll be doing this as a class for an activity. This is like the most basic way to look at the shape of the data. So then we have a dot at like 80, and then we have two 85s that we can stack. Then we have an 88 and a 90, two 90s, right? And 95 and two 100s. Okay, so what do you notice about the shape? The shape is okay. It's kind of flat. There's not like any one like peak that stands out, right? It's kind of flat. That's good. And what about, like, is it kind of balanced, like the left to the right? So it's a pretty symmetric, right? It's pretty symmetric. Okay, so that is a dot plot, and then we can look at this as, we can make a histogram from this. And a histogram is basically, we make these little buckets, and then we make a bar for every for how many values lie in that bucket. So the first thing that helps us is to make a frequency table. To do a histogram is how many times does each thing occur, frequency table. So we'll put our scores here and the number of times it occurs, so scores and the frequency. So let's say, what size do you think we should make our buckets? Well, we want to make sure that we don't have too few values. We don't want to make them so wide that we have too few values. Sorry, so narrow that we have too few values. So let's go from like 71 to 80. So how many 71 to 80, 81 to 90, 91 to 100. Let's just make three even. They all have to be the same width. So how many times do we have values between 71 and 80? You can look at the dot plot. Between 71, yep, 3 of those. How many between 81 and 90? We got 5 of those. And how many between 91 and 100? We got 3 of those. Great. So we make these evenly spaced. There shouldn't be any space between them. So 71 to 80, 81 to 90, 91 to 100, and then our frequency goes this way. So 0, 1, 2, 3, 4, 5. And then we just make a bar, so it's 71 to 80, there's 3 of them, right? So we just go up to there. 81 to 90, there's 5 of them, so that bar goes there. 91 to 100, there's 3 of them. And there's our histogram. So do you see how you can kind of see the symmetric shape better when you look at a picture of it rather than just looking at a list of numbers, right? That kind of gives you a feel for the shape. And you'll practice again with the examples today. And there's one more. It's a box plot. And you want to use these when you have, especially when your data isn't symmetric, like you might have outliers, and you want to use your median and your quartiles. So we'll get to review that with this last form. So this is called a box plot. It actually used to be called box and whisker plot. So we'll put some whiskers on at the end. So what this does is it divides up your numbers into quarters. So let's list our numbers again in order to do the box plot. So we have 77, 80, 85, 85, 88, 90, 90, 95, 100, 100. Alright, we're going to divide it into quarters. We start with the median. This is called a 5-number summary. So how many numbers are there? Where's the median?
11.
There are 11 numbers. So how many numbers up do we have to go to find the median? The 6th number, right? Cuts it in half. Median is like the 50th percentile is the median. So where's that? 1, 2, 3, 4. Okay, that's right there, right? So that's we label that M for median. And 50% of your values will always be below, and 50% will always be above. Now, quarter 1, remember that? Where would Q1 be?
77 to
You think it's between these two? People get confused on this. You ignore this dividing point. So you're only looking at the left half. What is the median of the left half? 80, good. So this is Q1, meaning 25% of your data are to the left. 50% of your data are to the left. Where's Q3? 95, good. Those are quartiles. Q1, median, Q3, and to do our box plot, this is obviously the minimum, and the number at the end is the maximum. So here's how you do your box plot. You put a vertical bar under all of these locations. So from the minimum, Q1, median, Q3, and the max. And then this, you make your box from the middle part, and 50% of your data is from Q1 to Q3, right? That's the middle half of your data. And then you make, these are little whiskers on the end. That's your box plot. And you can tell from this that the data is roughly symmetric, because half the values are from here to here and half the values are from here to here. The inner quartile range is Q3 minus Q1, but you already have that in your notes. And so that's how you do a box plot. Okay, you find those 5 numbers and then you make, okay, whiskers, well, these are your whiskers. Wait. There. Sorry. You don't have to add that. That's just for fun. Okay.